I will be moderating the first one, the one about the supply chains, and my introduction will be very brief. I just want to bring your attention to one important fact. We developed subsidiary research about the use of biomass at the moment of crisis. And what we discover, control of fuel supply is a key success factor. You cannot achieve success if you cannot control your supply. And in no time that was made clearer than during the current crisis unleashed by COVID and the war. I will just use some numbers. During this time, few months ago, diesel price climbed from 1.6 euro a liter to 2.2 euro a liter, which is a lot. It's 35% increase. At the same time, pellet price climbed from 4.5 euro a sack to over 12 euro a sack, which is an increase of 300%. So what that tells us is simply that it is really difficult to replace a fossil source. But it is even more difficult to replace an external source of biomass because the production of biomass is decentralized and the density and the value of biomass is so much lower that transportation cannot be justified unless you have an opportunity fuel. So imported biomass is an opportunity fuel that depends on very limited and quite precarious conditions. If you depend on imported biomass for your biomass endeavor, you are at big risk. So the most important thing then is actually guaranteeing the supply. And to do that, you need the right organization, the right techniques, and the right technology. And that is what we shall show during this first session about supply chains. So I think that we will go now with a video that will summarize what we saw yesterday here in Calimera, an example of supply from the management on olive grove management residues.
In Southern Apulia, South Italy, olive groves cover over about 400,000 hectares and produce excellent olive oil, which is exported to the rest of Italy and abroad. The crop is so prevalent that it alone represents 75% of the total agricultural surface of the area. It is estimated that pruning the Apulian olive groves generates over 800,000 tons of woody biomass every year. FIUSIS has turned the challenge of managing such a large amount of residues into an important business opportunity. The company operates 1 megawatt electric biomass cogeneration plant, which uses 10,000 tons of olive tree residues per year and produces 8 million kilowatt-hour of electrical and thermal energy. The plant has been commissioned in 2010 and has kept expanding its successful business ever since.
Olive grove management generates a large amount of wood material in the form of pruning residues, dead old trees, and rootstocks. Disposal is obtained by open-air burning, mulching, or landfilling. None of those options is environmentally safe, and all incur significant cost. The industrialization of regional olive tree crops has only exacerbated the problem by increasing the volume and the frequency of operations. FIUSIS has turned this problem into a resource by capturing the residue stream and channeling into a biomass plant capable of turning waste into a resource. That way, FIUSIS offers farmers a valuable service by providing cost-free, environmentally safe waste disposal while obtaining free fuel for their plant. For farmers, that is by far the best option, and that explains why over 2,000 farms have joined FIUSIS' scheme. Acceptance is unanimous, and wider participation is mainly limited by the plant's capacity, which points at a high potential for replication of the FIUSIS model. Residue collection is organized through a subsidiary company, Linea, which coordinates and supports a number of competent local contractors who have equipped with the most modern machinery. In particular, three main working methods have been adopted, corresponding to the three main residue types. Pruning residue is collected through a dedicated harvesters that pick up the windrowed branches from the ground and feed them to a shredder, which discharges the comminuted material into a built-in container. The container is designed for a high dumping so that it can easily transfer its load into a larger agricultural trailer or truck bin for transportation to the plant. Pruning residue harvester come in several models and sizes, and they can be designed for fitting to a farm tractor or a dedicated prime mover. Harvesting productivity ranges from 30 to 50 tons per day at a moisture content from 20 to 40%, depending on the season. A different system is applied to heavy pruning operations that generate overly large branches. Those are too big for the dedicated pruning harvesters and therefore are moved to the field's edge with a tractor carrying a front loader and later shredded with a mobile grinder, discharging directly into truck bins. Grinding productivity ranges from 50 to 100 tons per day. Olive trees can get very old, but they eventually die. Furthermore, industrial plantations are renewed when production declines, so indefinite aging is not an option. Regardless, old trees are especially vulnerable to disease, and they must be removed in order to contain the infection. Those trees are managed like forest trees. They are cut with chainsaws, moved to a landing, and eventually chipped with industrial chippers. The latter come in several models, but the most popular among industrial users are truck-mounted or trailer-mounted drum chippers, equipped with their own independent engine in the 300-400 kilowatt power range. Chipping productivity easily exceeds 100 tons per day. Once the diseased tree is cut, the game is not over yet. Part of the tree is left underground, and that must also be removed in order to contain the infection and to make space for a new disease-resistant tree. The stump and root are solidly anchored to the ground, and special equipment is required for their removal. In most cases, uprooting and size reduction are performed by tracked excavators in the 16 to 20-ton weight range. Given the variety of worksite conditions, operational models, and residue types, precision management is required. Special software is used to geolocate all farms participating in the initiative, plan and monitor operations, and eventually trace the origin and residue loads delivered to the plant in a 70-kilometer radius.
Okay, you just got a summary of what we saw yesterday in terms of supply chain. Now we'll have some brief intervention from manufacturers of technologies and developers of technologies for the harvesting of pruning residue and the uprooting of diseased trees. So the first one will be Michela from FACMA. FACMA will come with a presentation.
Good morning, everybody. I am Michela from FACMA. I don't know if you can see my face because I have shared the presentation now. Okay. We are sorry not being there personally. Unfortunately, we had another fair in program. We are very pleased to participate online to this workshop. First of all, we want to thank Raffaele Spinelli to have given us this opportunity and our customer FIUSIS for having shown our machines yesterday and having believed in our product to follow their objectives. Our company is in the center of Italy, in the province of Viterbo. It's been founded in 1971. At the moment, we have 65 workers, and our activity is the design, construction, and sale of agricultural machines. Our markets are for the 50% Italy, but for the other 50%, we sell all over the world, in Europe, but also in other countries of the world like Chile, mainly in Chile, because we are one of the supplier of Ferrero Group for their hazelnut orchards in Chile, Georgia, and Argentina. And we have 2 subsidiaries in Chile called Comercial Facmachile Limitada. The first photo is our seat in Vitorchiano, and the other 2 are our subsidiaries in Chile, where we also grow hazelnuts as a family business. Our product range is wide. In effect, we produce the pruning picker-up shredder that you have seen yesterday at work in Calimera, but we also produce other kind of machine, mulchers and flail mowers with interrow discs or not, for the grass cutting and for the preparation of the ground. And we are famous mainly for the shell fruit harvesters, to collect shell fruits from the ground, and also cleaning and drying systems. The shell fruits are hazelnuts, chestnuts, walnuts, almonds, macadamia, and pecan nuts. The pruning picker-up shredder has been invented by my uncle and my dad. In effect, our company is a family business, because in the shell fruit orchards, we have the exigency to collect the pruning residues and to take them away from the orchards. Because with the mechanized harvest, we shouldn't find pieces of wood on the ground. So for this exigency, we have introduced this kind of machine, which can be also used in olives or in other cultivation for the same purpose. The machine combi is produced in 3 models, 140, 160, and 200, which means the numbers mean the working width. In effect, according to the different cultivation, we can have a different working width. For example, in the vineyards, we use very narrow machine, 140. In the olive and in the hazelnut, we mainly use the model 200 because the distance between the trees is bigger and we can go with a bigger machine. The machine can crumble branches until 9 centimeters of diameter, creating biomass, because as you have seen yesterday, it crumbles the branches, making small pieces of wood. We can also apply some grids, and then there is a pantograph raising container which can unload in the ground or in other bigger containers. You can better see the technical characteristics in our website. With Raffaele Spinelli, we did many show days in the past for this machine in different kind of orchards, as vineyard, kiwi, also peaches, apples. It can be applied to all the cultivation which have this necessity to take away the pruning from the ground. I thank you very much for your attention, and we hope to see in the next occasion.
Thank you very much, Michela. Very interesting meeting, very interesting presentation. And yeah, thank you. We move to the next presentation now from RECO. So Mrs. Gilda Lisandra will present a pitch for RECO.
Io mi presento, sono Gilda Lassalandra, responsabile marketing di Vreco, e ho con me Anna Bressan, responsabile export, e che tradurrà per me, farà le traduzioni.
La traduzione.
Allora, niente, Vreco è un'azienda, si trova in provincia di Padova e nasce qualche anno fa nella produzione di macchine operatrici da 2 menti creative che appunto volevano sensibilizzare le esigenze del cliente e quindi hanno iniziato.
Hello to everyone. We are Gilda, which is Chief of Communication and Marketing here in VRECO, and I am Anna, Chief of Export. And we are here to talk about VRECO, which is a young company that was born a couple of years ago here in the northeast part of Italy, and from two quite creative minds that were very sensitive to the customer needs and in the manufacturing of the machinery, of operative machinery.
Ok, nel corso degli anni ci siamo specializzati nel settore del forestale, agroforestale, la manutenzione del verde, pulizia dei corsi d'acqua in genere e recupero e gestione della biomassa. Ed è appunto su questa cosa che noi in particolare oggi ci soffermiamo con la presentazione della nostra macchina VSE 1000 che è un'estirpa ceppi.
Mm-hmm. In the last few years, we specialized on the forestry and agroforestry sector, especially in the green maintenance and the cleaning of waterways and in general, the biomass recovery and management. So today we were focused on, in particular, on our WSE, which is uproots stump grapple. So we will see also, we had to see a video of it, but we will tell you what this machine do.
E la VSE è un'attrezzatura che viene usata appunto per rimuovere le ceppaie dal terreno, ma non solo. E in questo caso qua noi la presentiamo come un'attrezzatura che viene usata per l'abbattimento degli alberi di ulivo, appunto colpiti dal batterio Xylella. E questo tipo di attrezzatura ha una tecnologia sofisticata che semplifica e agevola la bonifica del terreno.
So this equipment is used to remove the stumps from the soil, but not only. It's a very agile equipment, very easy to use, which is useful for the felling of the trees that have the Xylella disease. So
quindi con la VSE in pochi minuti viene abbattuto un albero con un'unica attrezzatura, quindi estirpa la ceppaia dal terreno, la abbatte togliendo rami, tronchi e tutto, riducendo volumetricamente quindi l'albero.
So in a few minutes with this equipment WSE, you can fell off the tree and also do a volumetrical reduce of the stump and also its branches, because of course it uproots the stump from the soil, and also it is easier to then cut it and to use it for all different uses.
Ok, e questo quindi permette di avere delle agevolazioni, dei vantaggi innanzitutto sul trasporto, perché quindi la macchina riesce a ridurre questo materiale e quindi il trasporto diventa molto più facile. E in più sicuramente in una seconda lavorazione che è la creazione del cippato, e quindi diventa tutto molto più semplice.
So this, of course, helps to, first of all, help with the transportation of the material that are reduced, because, of course, it is easier to transport because it's smaller. And then we have, secondly, it's advantageous for the second elaboration works, which are, for example, the chippings. So you can also reduce even more volumetrically the stumps.
Quindi concludiamo dicendo che appunto la VSE trasforma un rifiuto in risorsa, quindi viene lavorato il materiale in maniera semplice ed economica, convertendo e valorizzando uno scarto che sarebbe difficile da smaltire in energia rinnovabile.
So we finish it with saying that this equipment transform the waste into a resource, and WSE allows you to work in a simple and economic way, converting and enhancing a waste difficult to dispose of in renewable energy.
Ecco, ci dispiace non far vedere, non riusciamo a condividere il video, a far vedere la macchina in lavorazione, però insomma, eventualmente vediamo se...
Yeah, unfortunately, we can't show you the video of the equipment working, so maybe we will show you like this in old ways. This is our equipment, the upstrip, the stump grapple, its great opening also helps to penetrate better the soil and uproot the stumps from the soil.
Ecco. Grazie mille.
Thank you very much for your attention. Wish you a good day.
We are really sorry that we couldn't manage to get your video online, but please send over the video because we'll post it in the project website for the showcase day. So that video is not wasted, will be available to everyone connecting afterwards, and people will be able to download, watch your presentation, and also see the video.
Thank you very much.
The machine could help very much progress in the field of uprooting. I mean, it's much more effective than trying to uproot a tree with a simple bucket.
Yes, also because
with a marginal cost, you get a substantial productivity increase in your machine. So thank you very much.
Thank
now,
you.
I think I will attend the presentation by Professor Murad Chanaki from the Academics University in Turkey, where pruning residue management is an important need and business opportunity. Please, Murad.
Good morning, everyone. Firstly, I would like many thanks to organization committee and especially Mr. Dr. Spinelli to give us the opportunity that I can introduce ourselves. Yes, my presentation is about the studies on valorization of pruning residues in Akdeniz University, Turkey. Yeah, the presentation is regarding it about us in general, what do we do and what we want to do for future. Our university is the one of the biggest university in our country. It was founded in 1972. It's located in Antalya. At the same time, Antalya is Mediterranean Sea city at the same time. Yeah, in our university, in total, there are more than 64,000 students and about 3,000 academic staff. In our faculty, Faculty of Agriculture has 9 academic departments. One of them is our department, Agricultural Machinery and Technologies Engineering. And in our faculty, there are 100 academic staff. And about 2,000 students are educated. Our department, in total, we are 8 academic staff, and we are occupying with different areas, agriculture, machinery, and energy use in agriculture. One of them is biomass, pellet production, briquette production, and valorization of pruning residues and shredding of pruning residues. When it comes to Turkey and agriculture, at the same time, Turkey is a big agricultural country. There are more than 23 million hectare agricultural area, and there are about 3 million farmers are occupied with agriculture production. When it comes to fruit production, especially the fruit production areas have been increased day by day in recent years. The food production area is 3,600,000 hectares, and it consists of 50% of agriculture areas in Turkey. The main crops are in orchards, in fruit crops areas, olive and grape in our country. Like many Mediterranean countries. Especially in the last years, the production area of fruit crops are increased. According to the statistics, 3.5 million ton per year residues are obtained from orchards. An enormous quantity chronic residues figure out in every year, and generally restricted operation are applied for evaluation of that. But recent years, some progresses have been seen in the subject. Removal and disposal of the chronic residues are started to be a problem in terms of cost, transportation, storage, times, and of course, environmental pollution, etc. Therefore, we are working in this issue for 15 years by taking needs and development related to this issue. First time, our studies tend to conventional shredders that chop the residues and leave on the soil. You can see some pictures from previous researches in field experiments. These are conventional shredders and chippers. At the end of these studies, as a team, we developed a self-propelled chronic residue shredder for the first time in our country in 2018. It was registered in beginning of the year. The self-propelled chronic residue machine worked in some orchards, olive and some lemon and the other orchards. These are our publication about in this issue. The interesting of the chronic residues are increased day by day because the number of plants whose residues can be used as raw material for their purposes are increased. For example, the total capacity of biomass energy centers is more than 1,000 megawatt for now in our country. So we started to work about the usage of chronic residues to raise awarenesses to use as raw material and biomass electric energy plants, to use as raw material pellet production, and to build a supply chain for these purposes. I can talk about our last two projects. One of them is infrastructure project for our campus. In our campus, area is about 350 hectares. We can say a green campus. There are a lot of trees or the other plants, and they are planted in some periods. And the many chronic residues are obtained from campus areas. We carried out with the project, we want to evaluate in terms of many aspects. And firstly, we built plants for chopping the chronic residue. We used different chippers and screen machine. And we worked on the other activities, not only education, but also research and extension services. And we used the materials in different areas. Maybe the picture is close to the event, this organization. The chronic residue sent to the electric energy plants to generate electricity, and we produced pellets, And the last project, at the same time, Mr. Dr. Spinelli is a foreign consultant in this project. The title project and investigation of the facilities of using chronic residues as feedstock in biomass energy plants. We try to make in different areas for solution of the chronic residues. We think to use many different methods and many different machines for this aim. The machine is produced in the first time in our country, the shredder with bin, with storage bin. The machine is the first machine produced in our country. In conclusion, the valorization of the chronic residues is important in Turkey in many aspects. Research and extension studies are needed in these issues. Many businesses and our country need to use these chronic residues in terms of bioeconomics. We want to benefit from lived experiences in Europe, especially Mediterranean countries. We are open to collaborate with the experienced teams. Thank you for attention, for your patience. Thank you.
Thank you very much, Murad. I'm really so happy that we managed to connect and to
Yes.
benefit from your most interesting presentation. I'll give the floor to Dr. Prince for presenting the Biomass Atlas, a Finnish good practice. Thank you, Robert.
Thank you, Raffaele. So hello, everybody from my side also. I will present now one Finnish practical abstract, so one case from Finland. And I will refer back to what Raffaele said at the beginning. So for this session, so the key is to secure the supply chain. And one of the parts of securing the supply chain is that you have to know how much biomass is available. So the biomass availability is a key when establishing a supply chain. And we have one solution in Finland that is called the Biomass Atlas. So basically, it is an open internet-based service for exploring the biomass harvesting potentials. And this service is available in Finnish and in Finland, and it has been expanded then to a few more countries. I will come back to that in a few minutes. But this service has been established in 2017, and the key is that it is based on the inventory data of the Finnish national inventory. And with that, we know exactly how much biomass is available and where it is available. So with the creation of the Biomass Atlas, we have an interface that allows to search, analyze, and report on the biomass availability in certain areas. The Finnish Biomass Atlas covers multiple biomass sources. So of course we have all the forests. Forestry is the key biomass here. So the forestry part, but it includes also agricultural biomass and biodegradable waste from communities and industries, so side products. So all kind of materials are included. You can see the link here if you want to have a more deeper look. And this is basically how this interface looks in practice. So since this is a Finnish service, now the language is in Finnish, but you can see the map here of Eastern Finland. And basically you can mark certain regions in the interface, and then it will tell you how much. In this case, it was selected about forest chips. So it will tell you small diameter trees, residues, stumps are included as well. So basically the tool tells spatially where is biomass available and how much. And basically it allows also this kind of center point search. So here you can see on the map in yellow here, we have established, for example, a potential new power plant that could be established, for example, in a location or a city or whatever place here. And then you create a map around that. For example, if you know how much biomass the plant will need, or in a certain radius around the biomass plant, you want to know in distance, let's say 50 kilometers radius, how much biomass is available, and then it will create this kind of map, taking into account lakes and other barriers there along the way, and it will tell you exactly how many million or thousands of cubics of biomass is available in which assortments. In this case, we have the first small diameter thinnings, residues, and also stumps, for example, in this list here included. But it just gives you basically information around a certain center point, how much is available in a certain radius, which is very helpful in the pre-assessment of, for example, new plant investments and things like that. So if somebody plans a new investment, it's very important already in the very early pre-assessment phase, how much is available, how far I need to go to get the biomass needed, etc., etc. And this service, the Finnish Biomass Atlas, has then been expanded in an Interreg project, Baltic 4Bio project, to also to Sweden and the Baltic countries. So in that case, the focus is purely on forest energy biomass. So that service has been expanded in Finland and Sweden. It is based on the National Forest Inventory data. And then in the Baltic countries, it uses other image analysis data as a background. But anyway, it tells basically in the similar way as the Biomass Atlas. It's based on the Biomass Atlas, how much biomass is available in certain regions. We can go to the next one. So some facts about that. So the Biomass Atlas in Finland was established in 2017. The expansion through this other project was in 2020 to the Forest Energy Atlas. And in that case, it includes only forest residues. Basically, what I would like to highlight here is that this service, it is well received in Finland, and it has got good feedback in Finland, and it could easily be established also elsewhere. And for example, since this project is about knowledge transfer, technology transfer, we are at the moment having a project where we try to expand this service, for example, to a case area in British Columbia in Canada. So it is not limited to certain areas, and basically it is a good example. In Finland, it's well established, it works well. And why not expanding that to Italy or any other region that is of interest? The key part I still want to highlight is, of course, the data that is behind that. So that is a key. We need the data behind it. But once we have a data, there is a solution how to make it useful for end users and those practitioners that use that information. So thank you very much.
Thank you very much, Robert. So I think this is very important what Robert presented. We just said that control of fuel supply is a key success factor to all biomass fuel endeavors. And of course, control of fuel supply starts with a good knowledge of the fuel availability. This is what you can get through the Biomass Atlas as shown by Robert. At this point, given the technical hurdles that we need to overcome, I would suggest that we stop for a brief coffee break, 15 minutes, during which we restore our energies, and also our technicians will solve the communication issues before we start with session 2. The question and answers might be postponed and lumped with the question and answers to session 2, because at this point, it would be difficult to make sure we can connect everyone who wants to ask a question and we can answer correctly. What I would like to do is to draw a conclusion for the session, a very quick one. And the conclusion is pretty straightforward. What we've seen is that fruit crops in general, all over the world, in the Mediterranean or outside the Mediterranean or in Chile or wherever it is, produce a large amount of residues. So the management of these crops produces residues. These residues represent a burden for the farmers, and biomass offers an opportunity to turn this burden into a a more efficient chain and an economical opportunity for the whole community if this material, instead of being wasted or landfilled or burned, is brought to a biomass facility and used for a productive and efficient purpose. FIUSIS offers a very clear example of how that can be done and is actually done. And it has been done for the last 13 years. So it's not anything, it's not science fiction. It's something that is being done, and it should be replicated wherever fruit crops are prevalent, reach the critical mass, and suffer from a lack of efficiency in the management of residues. So thank you very much. At this point, I will give the floor to Dr. Pignatelli, who is the moderator for session 2 and 3.
Thank you.